In this video, I will be giving a brief introduction about the topic sound. In this, we will deal with the main concepts about what is sound, how it is propagated, and the characteristics of sound waves. Okay, first let's see what sound is. Sound is a form of energy. It is a form of energy which causes a sensation of hearing in our ears. So, what we can say is that it is a form of energy which our ears is able to pick up. Now, sound is produced due to vibration of objects. That is, if an object vibrates, it produces sound. For example, if we hit hard on the desk with our hand, we can hear the sound. And we can also feel the vibration going through the desk. Now, sound propagates through a medium by transferring the vibrations to the particles of medium. That is, sound is propagated through medium by exchanging energy into the particles of the medium, and when the energy is exchanged, the particles of the medium also goes into vibration, and these vibrations are passed on to the nearby particles, and thus sound is propagated through the medium. Hence, we can say that sound propagates as waves. That is, in case of waves, there is no actual movement of a particle, only the to and fro motion. That is an oscillation only of a particle between two positions occurs. That is the disturbance. Now, propagation of sound as waves. How is sound propagated as waves? The form in which sound is propagated as waves consists of compressions and rarefactions. Compressions are in which the particles are compressed together and it's a high pressure area. While in the case of rarefactions, the particles are loosely packed and it's an area of lower pressure. Since the sound travels in the form of compressions and rarefactions, sound waves are longitudinal waves. That is, the oscillations occurs in the longitudinal direction. As seen in this figure, we can see the rarefactions and compressions. When a vibration occurs, the initial vibration compresses the air. In the case when sound is transmitted through air, the initial vibration causes compression of the nearby air particles, causing the compression. After some time, when the vibration eases up, the pressure near to the area decreases and hence it causes rarefactions. And thus, through compressions and rarefactions, the sound waves are propagated through air, as shown in this figure. Now, this is important. Sound needs a medium to travel. It cannot travel through vacuum as light travels through vacuum. The medium can be solid, liquid, or gas. Now, since sound waves can only travel through a medium, that is, it can travel only if a medium is present, it is called mechanical waves. So, sound waves are mechanical waves. Now, this can be proved by this experiment known as the bell jar experiment. In this case, a bell jar is fitted with a electric bell as shown in this figure. The bell jar is tightly closed using a cork and the bell jar is connected to a vacuum pump. At first, the bell jar is filled with air. Then if we switch on the electric bell, we can hear the sound. Then what we do is we switch on the vacuum pump which sucks all the air out and hence a vacuum is formed inside the bell jar. Then if we switch on the electric bell, the bell is inaudible. Hence, we can say that a medium is required for sound to propagate or travel. Now, characteristics of sound waves. This is a representation of the density or pressure and distance in the case of longitudinal waves. It is a sinusoidal wave. Now, first characteristic of sound wave is amplitude. Amplitude is the total height of the crest or trough. As shown in figure, it is marked by A. Amplitude of a sound wave varies according to the force applied by the vibration. For example, if we hit hard on the desk, the sound becomes louder when compared to hitting it with much weaker force. Now, wavelength. Wavelength is the length between two consecutive rarefactions or compressions. In this figure, lambda is used to indicate the wavelength. The unit of wavelength is meter. Now, frequency. Frequency is given by the reciprocal of time period. It is the number of vibrations happening in 1 second. Its unit is hertz. It is denoted by the Greek letter nu. Now, speed. Speed of this sound wave is the distance traveled by it in 1 second. The speed of a sound wave varies according to the medium, the temperature and humidity. It is faster in when the medium is a solid, less fast or slower in case of liquids and really slow in case of gases. When temperature increases, the speed of the sound waves also increases. Similarly, in the case of humidity also, with increased humidity, the sound waves also increase in speed. This is the end of this video. In this video, I have covered just some basic concepts regarding sound. If you have got any doubts in the mentioned topics, you can comment in the section below this video.